احنا دلوقتي موجودين في ال AI والروبوتكس والميكاترونكس لاب. اللاب اللي اتكلمنا عنه كتير جدا جدا وشفنا له صور. اللاب اللي حجم الانفستمنتس اللي UCSI حطها فيه يقدر ب7 مليون رينجت. زي ما انتم شايفين الآلات دي كلها من سبلايرز ألمانية، سبلايرز أمريكية، كلها روبوتكس ليها مهام معينة بتعملها. علشان نتعرف عليها أكتر يعني هيكون معانا أحد المحاضرين اللي موجودين هنا في المعمل الخاص ب UCSI، هيشرح لنا كل روبوت من الروبوتات دي إيه المهمة بتاعته بالظبط.
Robotic arms. Okay, this one we actually intended to use this for teaching students. Okay, students will actually get to play with this. Okay, we have the controller over here. This one.
Okay, so this is the control.
Yes, this is a controller. Okay, the student will get to program the codes. Okay, for it to move. Okay, so we have a few activities for students. Okay, first activity is like this one is actually obstacles. So student need to change the effector into the ring shape so that the hook will actually get to move along these obstacles. So it's like path planning. So they get to visualize and then do a lot of challenging movement tasks, plan how it's going to move. If actually it touches the obstacles, then it means that the game over, something like that. Okay, so right now the same thing for all the robotic arms. So this one, effector, we can change it to any kind of things to suit the application. For example, effector we can change it to a scissor, pick and place, okay, or just a blower to blow something. This one is actually directed by our top management. It's because of Chinese New Year, so we wanted to train the robot to write Chinese words. Between these Chinese words means dragon. So because this year is the year of dragon.
Oh, that's perfect. So this robot can make a lot of
Yes.
Yeah, a lot of things and in a lot of industries as well.
Yes, correct.
Yeah.
But when you see it's tabletop, means that we use it for simulation purpose, teaching purpose.
Okay. So the students can come like for the AI and mechatronics, robotics, and all of them can come here in this lab.
Yes,
and make a simulation for it.
Yes, by right, this is our signature laboratory for Industry 4.0. So we have a lot of laboratories. This is our signature lab. And so far, we are still improving our courses. Right now, only mechanical and mechatronics. Okay, we integrate the course for using this robotic arms for manufacturing line because they have one course involving manufacturing. But in the future, we are going to continue to improve and let other courses to join our program.
Oh, okay, that's perfect. And what about this one? It's different, like a different mission for each robot, right?
Okay, so this one is actually a spline robot. You can see that it's spliney, right? So, okay, another thing is we also call this as cobots. Cobot means collaborative robots. So when you see this one, okay, this is actually the current trend of industry in a way that you can choose not to program it. You don't even need to know codings. Okay.
Oh, so the student can do everything directly without making coding or something like that.
One example is if you want the robot to move and pick these items and put in the basket. Okay. So you just need to move the robot here, close the clip, then the robot will calculate
by itself. Oh, okay.
You calculate forward kinematics and inverse means that return back to original position.
Okay. So each brand of this robot, Doctor, like Kuka, or this is a very famous brand in this field.
This one is Omron.
Okay.
Omron is top-notch automation company in US.
Oh, that's perfect.
Yes.
I think it's so expensive.
Very expensive.
Oh, okay. So. And the other robot, the same, make the same things or different?
Oh, this one is actually Okay, this one we actually refer as a flexible manufacturing line.
Oh,
Okay, flexible manufacturing line in a way that, for example, in production line, okay, if you know that in production we are doing batch production, batches. So, for example, if we wanted to make a triangle car, a triangle tire or something, a product. So the production is fixed already.
Oh.
You can never change it. If you want to change it to rectangles or circles, sphere or something, we need to buy a new production line.
Oh,
this is
so
very
you
expensive.
have to get like a package or a group
Yes.
for the production
Yes.
line to get the product at the
Yes.
end.
So that's why this is called flexible manufacturing line. So FMS. So it means that we can actually program and change how it process these shapes. So currently everything complicated user demands. Okay. So it drives us to seek for programmable, so flexible lines. So if we wanted to accommodate it to new design changes, everything happens at our fingertips.
At the moment.
Yes.
Okay, so the companies for each one make like a maintenance or something to avoid anything wrong in this machines or in this robot.
This one is made by Festor. Festor is very, how to say, it's more on to focus on specializing in doing this flexible manufacturing line for education purpose. But this one actually assimilate the actual production line.
The actual production line.
Okay, like for example, did you see that these rollers means that we can actually interchange the position. So the students can make different structures, series, parallel or something. Okay, then they can count. Okay, they can with this they can reduce the cycle time. With this they can reduce the cost. Okay, something like that.
Like full control. Full control to
Up to them, they can design.
Yeah.
And if you notice, every mini station is actually corresponding to one manufacturing task. Like for this is actually a warehouse. Warehouse. So far, this production line is specialized, already customized by Festor in doing packaging of our fuse box.
Oh.
So this one is the fuse boxes. So this is like a warehouse. It will keep and then move here. Here is
here.
like a sealer. Capping, sealer. So
Then go in this.
now you see that there's a shutter over here.
This.
Shutter. So if let's say you don't want the robot to go through this pick and place or go through the milling machine, okay, so you can just open this. The robot will keep on moving to form a circle. It will never enter here.
Oh, okay. So the product will not go inside. Just go in this this line.
Yes. So if you want to have pick and place, and if you want to have milling is like drilling process. So you can just let it to pass through.
Oh, okay.
That's why everything is customable, programmable.
Depends on the design that you are working on. Oh, this one is very impressive. The big one.
Okay, this is what I mentioned just now. Okay, remember what I mentioned is tabletop. Okay, tabletop, that one. Okay, is on top of tables. This one is on the floor, and this is actually means industrial graded robotic arm.
Oh.
So this industrial graded arms, okay, is what actually being used in the industry. Like for example, car assembly.
The cars.
Tesla, Protons.
Oh.
They use about 4 of this to assemble one car. So with that, it will be faster, okay, more productivity, lesser error, okay, higher efficiency. So again, the same thing, the effector can be changed to do drillers, pick and place, this and that.
Yeah, I see this one in the factors of the car, like assemble the parts of the car and so on. Yeah.
And the brand is KUKA. KUKA is from Germany, and also is currently the #1, the most famous supplier and robotic designer.
Oh, okay. So how much for the cost average? Because I hear that like UCSI invests like 7 million ringgit or something just on this lab. So this for example, the average of this robot.
This one I've forgotten, but that manufacturing line, a few millions.
Yeah. Okay.
Just that line.
This line.
This line only, a few millions.
Ooh, that's perfect. So impressive. Okay, so the student don't want to after the graduation, like he took already a training for everything to be ready for the work
Yes,
and
yes.
for the workforce. And this lecture room,
Okay.
like
This one we are trying to implement education 4.0, which is also the current trend of education. So you see that there's a camera on top, right? Something
on the
like
top. Yeah, this one.
That one is actually for projections. Like sometimes we have a lot of programs like Star Trek or exchange programs, or we even we also invite Australian French students to come here. I think last week we just have our Korean students. So if let's say the student's not able to come here, or the professor is not able to come here, or we invite outside professor, we can use that camera and internet connections to project.
To make it like online or something,
A
and
remote study.
remote study. I see the students already working on a project or a product or
But
something.
now they
like
are
that.
having STEM activities, so
okay.
the students come here to have a small collaborations to let them experience what it's like in campus.
Oh, okay. So different year, like in year, second year, third year, it's not just the final project or something.
We also have postgraduate students.
Postgraduate students here. Oh,
If you see the smart board over there,
this one.
electronic smart board. Okay, now we are practicing that. Okay, because using that, the student don't need to come in front of the classroom to draw. They can just draw on the iPad and they share that.
It's gonna show up in the on the smart board.
Yes.
Oh, that's perfect. Okay. I think I have to come again to the lab. Yeah.
If you notice, all of our labs is actually being integrated with motion sensor. The time when you come in, it will light up immediately.
Everything, yeah, I noticed when I enter everything like censored and like gets the faces and so on.
Okay, that one is facial recognitions. Okay, if let's say your face is not recognized, it will hit a red color mark, right? So you need to register to our lab portals. Okay.
That's first, yeah.
After they identify your identity, then when you enter, it won't show you the red color, but it will show you your identity.
Oh, okay. So you don't need like access card or something, like recognition of the face. That's it.
Right now we haven't reached there yet. Right now everything we only let engineering staff to come in here.
To come in the lab.
Only for us we have that.
Yeah. Okay. Thank you so much, Doctor. I appreciate your time. Thank you. Thank you so much.